Welcome to Stine Seed Farm Tour. I'm David Thompson. We're going to be talking about all the things that make Stine unique in our business, from soybean breeding to corn breeding and development to our innovative production practices and our biotechnology facilities. To start things off, we're going to talk about a little overview of the company. I've got Myron Stine here with me. Myron, what can you tell me about the history of Stine Seed Company?
This farm that we're standing on right now was actually farmed by my grandfather in the 1930s. And then my father took that over. And then in the late 1960s, he began soybean breeding. Late 1972, 1973, he began corn breeding. And then late 1970s, we began our retail brand.
Give me a snapshot of where we are today then.
So today, if you look at our soybean program, we're considered one of the most successful and the largest soybean program in the industry. A majority of the genetics planted today are derived from our soybean program. If you look at our corn program, 75% of the corn that Stine brand sells today is a proprietary hybrid that has an inbred line that has been developed in our corn breeding program.
Wow, pretty neat for a family farm in Iowa. So obviously our business is very competitive. I mean, what does it take for Stine Seed Company? What has it taken for us to be successful? And what do you think it's going to take for us to be competitive in the future?
So we really think there are 4 different items that a seed company will need to deliver product to the farmer in the future. And the number one thing is germplasm. So we feel that between our 2 breeding programs, we have 2 of the most successful germplasm bases in existence right now. The next thing would be traits. At this point, because we're a privately held, smaller company, we're able to collaborate with a number of people because they'd like their traits in our germplasm. Whenever we do a collaboration, we want to make sure that our brand has priority access to that technology. So we have the traits. We also have a biotech division, which has our own transformation technology. And that allows us to put traits and things into our germplasm, no strings attached, which is awful nice. Then the last thing we have is we have a channel, or we have a way to get that product to the farmer. So we have the 4 components to be successful.
So really for Stine customers, the payoff is the traits that they want and quality genetics from Stine for maximum yields and profitability.
That's correct. Yield is everything that we focus on.
And ultimately, it all adds up to profitability for our grower customers.
Absolutely. That's our top focus.
Great. Thank you, Myron. So that's an overview of Stine Seed Company, and we'll also learn more about our corn breeding program, our soybean breeding program and testing program, biotechnology resources, and some of the innovative production practices we have here at Stine. And ultimately, it all adds up to our commitment to our grower customers, to provide outstanding products for maximum yields and profitability. You know, one topic that's getting a lot more attention lately is corn planting populations, and that happens to be a topic that we at Stine feel very, very strongly about. This morning I've asked Myron Stine to join us to talk a little bit about that topic. Good morning, Myron. Good morning, David. So before we get started, can you tell me a little bit about the history and the background of corn plant populations?
Yeah, absolutely. So back in the 1930s, a productive farm may plant at 8,000 plants per acre, and they may get a yield of 40 to 50 bushel per acre. Today, a productive farm may plant at 37,000 to 40,000 plants per acre, such as this field right behind us. This is planted at 40,000 plants per acre. And you'd get yields, you know, today you can get yields of 200 to 225, for instance. What breeding companies have done is essentially manipulated genetics to stand higher populations. So you essentially today have corn that you can plant thicker and put the same amount of grain on per plant. We've seen this trend line. We don't think it's going to stop.
So the key, what you're saying is the key to this growth in yield has really come from not, you know, making more grain on the plant. It's just putting more plants on that acre.
That's very true. That's exactly what's happened over time.
So what are companies like Stine doing to work with that, and how do, you know, once you understand that, what are we doing to further that cause and work with high populations?
So our company, we'll take our germplasm base that we have, and we continually mix that germplasm base up, and we subject that germplasm base to that high population environment. When we find plants that do well in that high population environment, we then obviously take those plants and cross them with other plants to make more plants that way, and we slowly will push our germplasm bank and base that direction.
So what kind of populations is Stine looking at in those kinds of environments?
So today in our elite yield trials, we will plant at 36,000 plants per acre, 48,000 plants per acre, and 60,000 plants per acre. At the same time, we're assuring that we have the nutrients and the resources for those plants to perform in that high population environment.
But you're not recommending the growers plant at 60,000 plants per acre?
Absolutely not, absolutely not. Today's plants are, they're geared for a higher population, but maybe not that high. We're trying to stay above the curve. And everything we're doing today is so we have products, say, in 10 years that are able to.
So you're testing, testing to the extreme to find the hybrids of tomorrow.
That's right. That's right. If we don't do this work today, we won't have the right product for our customers in 10 to 15 years.
So, if a grower's thinking about, changing his plant population, what are the considerations he needs to be thinking about as he makes that transition?
Well, the number one thing that everyone needs to understand is that there's a general trend for higher populations. However, there's hybrids that are on the lower end of that trend. There are hybrids that are on the upper end of that trend. A farmer needs to understand what his hybrid's capable of doing. If you look at much of our product lineup, we're on the upper end of that trend. We have some competition out there that would be on the lower end of that trend. So they need to understand their hybrid specifically. Then once they figure that out, they need to make sure they have the right resources for that hybrid to perform on the acre, such as the right nitrogen applied, the correct micronutrients. Do I need a fungicide? The right farming practices to make sure that that product is able to perform at its best on the acre.
So it's not just the hybrid, it's an entire system, really.
That's right. It starts with the genetics, but if you don't have everything to back the genetics up, it won't work.
Well, and that's the key, and that's something that, like I said, I think a lot of growers are talking about and thinking about with regard to high populations. So appreciate you visiting with us, Myron.
Thank you.
Yep. The Stine name has been synonymous with high-yielding soybeans for nearly 4 decades. And it's through the research and dedication of our soybean research team that's happened. I've got Rodney Pinnico here. He's a research team leader with Stine. Rodney, what's going on in this field right here?
Well, this is our crossing block. We're making all our pollinations for the summer. This year we've made over 9,000 crosses here in this crossing block, which is over 60,000 actual pollinations. That's in addition to what we do in our winter crossing blocks for this year, which we did over 6,000 crosses. So totally, we've done over 100,000 pollinations this year.
What's it look like? What's a hand pollination look like?
Well, here's Teresa. She's doing a cross at the moment. We predetermine our crossing schedule, what we're going to do in our program per year, and the crossers will make those combinations. Teresa's here is making a cross. She's already picked the flowers that we're going to use as the male. She's cleaning around the bud of what she's going to pollinate, and we're actually going to take the pollen from that flower and pollinate that bud that she's working on. She's going to tag that, put the cross number on that tag that she is working with, and initial it, and we'll come out in a week or so and see if we got a take.
So because soybeans are self-pollinated, you have to actually take pollen from another plant to make that cross.
That's right. It takes very steady hands and a lot of patience to do this job, and it's a very tedious process for the whole month of July that we work on this.
And you do that 60,000 times.
Yeah, so it takes a good steady crew to make that work.
Wow, that's amazing.
Thanks, Teresa.
Each year, the task of finding new soybean varieties falls to our soybean research team that runs our elite testing program, and they test and evaluate new lines of soybeans for us. Every year we test and evaluate hundreds of thousands of new lines with hope of finding good varieties. This box here represents a set of entries that will be taking place in this year's elite testing program. Each of these envelopes has seed in it, which is a new variety that's being tested. and each of these boxes holds 40 entries, and these are the boxes they'll take to the field and actually plant that seed this coming spring. As you can imagine, when you're testing and evaluating more than 900,000 lines of soybeans, it takes a lot of boxes to come up with what we hope are 35 or 40 new varieties at the end of the season. So Rodney, tell me a little about the timeline of how this all works from the point we cross till a grower might see something in a bag.
Well, we're looking at 5 to 6 years, Dave. The crossing that we're doing here on our farm today, we're going to, at maturity time, which is sometime in October, we're going to be pulling those cross seeds off. Each one will be one pod. We're going to hand thresh that pod, and we're going to turn 2 generations in Florida from that seed. So we got a nursery that we're working in Homestead, Florida. So we'll take that seed and we'll send it to Homestead, Florida. And we're going to turn 2 generations. We're going to plant it in November. We're going to reharvest it in February, replant it, and bring the seed back here to May. And we're going to have bulk populations, which will have 400,000 to 500,000 bulk populations from this cross seed.
So you've got 500,000 new varieties just derived from the crosses you made a year ago here.
Exactly, and we're gonna hand pull those plants, and we're going to run each one through a hand threshing machine, and we're going to thresh that seed, and we're going to send it to our South America, Argentina site, and we're going to increase that seed to bring it back to put it in our first year yield trials, which we'll have 1 rep at 6 locations. There'll be 6 row plots. We'll harvest the center 4 rows. We're on 20-inch rows. So we'll take lodging data on that, and we'll pick high yield and good lodgers and pick the top 7% and try to weed this down as we go along into the next phase of our yield trials.
So at each stage of the game, you're keeping just a few percent of the total
Exactly.
varieties.
We start with a few thousand, and then everything that makes it out of that first year yield trials, we're going to trim that down and keep top 5 to 7%. We'll be down just to a few thousand. And as we move into the elite trials, we're down to a few hundred varieties, which will turn into marketing, just a few less than 50 lines out of that generation of seed will actually make it to market.
So from 500,000 lines down to maybe a few dozen. But that's what you have to do, I suppose, to find the very best stuff.
Because the pipeline is always full, so we're always weeding the top of the top out each time, and we got new stuff coming. So we're always rotating the seed lines for our growers.
Tell me this, Rodney, what makes Stine such a successful company when it comes to soybean breeding?
Well, it takes a lot of dedication. We got a hard-working crew that's been here a long time. Everybody is dedicated. It takes a lot of hard work, a lot of long hours, but that's what it takes to make a strong seed company like Stine.
Thanks, Rodney. And it's that kind of commitment and dedication to quality that's kept Stine a leader in soybeans for nearly 4 decades. When you develop hundreds of thousands of new soybean lines every year, it's very important that you have a system to evaluate those products to find the very best lines. And that's the job of our soybean research team. I've got Rodney Pinnico here, as a soybean research team leader with us, and he's going to talk to us a little bit about the process they use to evaluate these products. Rodney, what can you tell me about this piece of equipment we've got here?
Well, when we do research plots, it's all about precision. So on these tractors here, we run GPS, so we can also run auto steer and our tripping system on our planter. That's a very important part of our research program. The planters are all set up with a splitter system, so we can package 1 envelope of seed and split it into 3 individual rows. The plots are actually a 6-row plot where we harvest the center 4 rows. So we take 1 envelope and actually put it into the seed splitter that we have here. It diversifies the seed into 3 equal units, which goes into these 3 row cones on this side. As we move through the field, every 9 feet is our plot length, and we leave a 4.5-foot alleyway. The GPS will coordinate to when to trip the cones and the seed down.
So everything's right where it needs to be. Now these rows look a little narrower than what we're used to.
This is new for our program this year. We are on 20-inch rows this year. We plant a 6-row plot. We harvest the center 4 rows. That's part of our ongoing development on higher populations in soybeans. These planters are used to plant corn and soybeans. So it's a very unique part of our operation today.
Now, about how many plots did you guys plant this year with this equipment?
We planted 900,000 plots with these planters.
we get to harvest season, obviously you've got all these 900,000 plots. Tell me a little bit about how we go through that process.
These are some specially made research combines. These are set up with this new row configuration we have. Means we went to 20-inch rows. We had to redesign the headers for these combines. So this is set up to do the 4 harvested rows out of the 6-row plot. The plot is harvested. The seed comes up into the combine. It's got a rasp bar cylinder similar to a farmer's combine. The unique thing is about this machine, it has air clean out, so we can clean every plot sample in around 5 seconds. So every plot comes through the combine, goes through the cleaning system. The clean seed comes up through the air delivery system into this weigh hopper. This weigh hopper on this combine will take the weight. We have a computer on this machine that will actually log all the test weights for every plot. And after we take that data, we have the option of either discarding the seed or keeping the seed. We evaluate this before the season on what plots we're going to keep for reused seed and which plots we need to discard. If we're going to discard the seed, it goes into a cross auger, which goes into the grain tank. We can discard the seed into a grain wagon. If we do decide to keep the seed, after it goes into gets collected out of the weigh system, we can collect that sample into a mesh bag. We have a tag that's set up that goes with each individual plot. We'll tag that plot sample. And on the side of this combine, we have an 8-rag bagging system where we can put seed sacks on here. So we'll take those harvested samples that we're going to keep, and we'll put them in the bag that's properly set up for the plot layout. We'll take them to the warehouse for storage.
And that seed will be used in future evaluations for another trial.
That's correct.
Further evaluation.
That's correct.
So, I guess give me an idea. Obviously, you've got 900,000 plots to get through. I mean, you obviously have a lot of work to do. How many plots in a day do you hope to get done with this equipment?
When we're bagging the seed, we can do 1,200 plots in a given day. If we're discarding seed, we can do anywhere from 2,000 to 2,400 plots in a day when we're discarding the seed. So the amount of seed that's harvested in a given day per combine is very good.
But at the end of the day, if you're going to find the very best varieties out there, that's the work that has to be done, isn't it?
That's correct.
Thank you, Rodney. So as you can see, it takes a lot of effort to come up with the very best lines to offer to our grower customers, but that's our commitment to offer the highest yielding products and the traits growers want for maximum yield and profitability. Although the Stine name is best known for soybeans, what you may not know is that we have a very comprehensive corn breeding program. And I've asked Dr. Keith Campbell to join me today to tell us a little bit about our corn breeding program. Keith, tell me what's going on here in this corn nursery.
This is actually a 15 to 20 acre nursery that we have here at Stine. We run this here every summer. Typically, we do about 300,000 hand pollinations out here. Size of the nursery is right at about 20 acres. Essentially, with a hand pollination, you're putting these white bags, known as a shoot bag, over an ear shoot, and then you would typically have this brown bag up on the plant that you're going to make the pollination on. That would leave it up about 24 hours to collect pollen. The process works, you remove the shoot bag and you put this brown bag right over the top of this at the same time, thereby making a pollination. Again, we do about 300,000 of these a year, these hand pollinations. We're in the process out here of developing right at about 40,000 different inbred lines out here at different stages of development.
So this is to create, pure inbred seed as a foundation for our breeding program.
Correct.
Are there a lot of companies involved in the inbred development process?
Well, there's a lot of companies in the industry that say they do their own breeding work. The reality is there's only a handful of them that still do breeding, especially on this scale. And there's some of the majors, and then there's Stine Genetics. We've been doing this for 20-some years. Essentially, the numbers have gone up every year in terms of the number of pollinations, the number of inbred lines in development, and we truly are proud of the fact that it's our own genetics going into our own bag.
What are the different options out there for growers? We know there's a lot of traits out there. How is Stine positioned when it comes to the trait side of the business?
Well, we can access all the traits in the industry, whether it be Monsanto traits, whether it be Syngenta traits, the Viptera traits, or whether it be the Dow traits. We work with all the genetic providers and put the traits that make sense for us, for our growers, into our own genetic packages to put into our own bag.
Great. Now, of course, having a lot of numbers is one thing, but figuring out which ones are the best is something altogether different. So how do we go about finding out the very best genetics in our system?
So essentially it's a two-stage system. Number one is development of these inbreds. So we'll self these down about 9 generations. We get a finished inbred. We put it in combinations with other inbreds to determine which are the best products. We put them into our testing program. Testing program is a pre-elite system, followed by elite, followed by our yield in the field, which is basically our strip trial program. We're looking at probably 2 to 4 or 5 years of testing on each of these new inbred combinations into hybrids, and roughly 3% of these hybrids, and there's roughly 10 to 20,000 new hybrids we put into testing on a yearly basis. Roughly 3% of those will make it from the pre-elite stage through elite through the final yield in the field testing stage.
So all of this work will end up in a dozen or 15 new hybrids that a grower is going to see each and every year.
Correct, correct.
What, you know, the trait business creates a certain wrinkle for the corn industry in having to get the right traits into the right genetics. Mm-hmm. Tell me a little bit about things that Stine is doing to try to speed up that process.
Well, we use what we call our fast generation breeding program, which essentially we go to South America in the wintertime. All these ears that you see out here that have been pollinated, most of these will go to our Guyana program in South America. The system down there is we can generate a new inbred or a new generation of corn every 90 days. So essentially in a year we can put 4 generations of corn through our Guyana program for trait integration, putting either Monsanto or Syngenta traits into our own germplasm, blowing up seed stock. You know, we can go from basically an ear like this in a row to about 200 acres of production within 4 generations in Guyana. So we can go basically brand new ear, finished line, commercial testing to Guyana to blow up a seed stock, come back here and do production out the following year.
So it's all about speed, all about getting that product to market faster.
Speed to market, exactly.
So what do you, when you talk to growers, you know, what's the takeaway message you want growers to understand about all the work that goes on here?
Well, something that we're extremely proud of at Stine is it's our own genetics that we've developed out of our own nurseries that you see here, that you see in Guyana, and our own testing program. We do all of our own trait conversions, Syngenta traits, Monsanto traits, put them into our own germplasm. So it essentially gives us a unique combination of our own genetics and traits that make sense for our own growers.
So ultimately, what's, you know, at the end of the day, what's the payoff for our grower customers of all of this work and all of this effort that goes into this program?
So the final payoff is you've got unique genetics going into a Stine bag, not offered by anyone else in the industry, and we've always been known for our yield. We definitely are looking at yield, so top end yield on all of our genetics. Very good stalks, very good roots on the corn plants, plants that can handle higher populations. We test everything in our pre-elite and elite at about 42,000 plants per acre. So we're also a leader in the industry in terms of plant populations and testing. So we're pretty proud of that fact as well.
So the bottom line is traits growers want and unique genetics available from Stine Seed.
You summed it up very well, David.
Perfect. Thank you, Keith.
Thank you.
Back in 1991, when Stine Seed Company got involved in the seed corn business, we had a lot of decisions that we had to make, and one of those is, what do you do about seed corn production? You know, when you do seed corn production, it's got to be done right, because you want to have a quality product and preserve the yield that's in that corn that you've created. So we sat down and came up with a system we call our Field Max seed corn harvesting system, which is really unlike any other system out there. We've got Steve Luther here as Assistant Farm Manager at Stine Seed Farm. Steve, what can you tell me about this machine we got sitting here?
Well, what we have here is one of 3. It's a seed corn harvester. It started life as a John Deere 9600 combine that we, as a company, engineered and took to a different level. What we do is we bring everything in a main belt, and as it makes its way to the back, it comes across a splitter belt. It comes across our shakers, through the husking beds, up the conveyor to the top, where it is then sorted on top for purity, off types, and anything that's unhusked gets sent through a return. And what we're doing here is You know, we're just doing it all right here in the field. We're handling the grain less. Once it's off the machines, that's the last time we touch it.
Great. So who built these machines?
We did here at Stine, just a collective group of us that work on the farm. We did all the work ourselves.
Fantastic. So really, yeah, what you're trying to do is take care of in the field what would normally be done on the factory floor.
That is right.
Okay. Tell me a little bit about how the process works, how this fleet operates once we get into the harvest season.
You know, we typically start around Labor Day, and with all three machines we start then. We run 24 hours a day. Each machine has its own crew of 12 people per shift, and we typically run 4 to 5 weeks until we're done.
And the goal is to get everything in safely and in timely fashion.
That's right. We're trying to beat that first frost, so we don't waste any time.
Absolutely. All right. Thanks, Steve.
You bet.
So that's how the FieldMax harvester works, and from there the seed goes off of this machine and gets loaded into these drying boxes where it'll be hauled into our drying stations. When the seed corn comes in out of the field, it's brought into these drying stations. Each drying station holds 4 boxes, so we'll stack them in here 2 high, 2 across, and each box holds 125 bushels of wet ear corn. Now, each station is anchored by one of these fans, and that fan will be used to push air through those 4 boxes of corn. And it usually takes about 2 to 3 days to get a box of corn dry enough to process. Now, the beauty of Stine's system is we're drying it in small batches, 125 bushels at a time. That allows us to use extremely high volume of air and relatively low heat, thereby preserving the grain quality and preserving the quality and the yield of Stine seed corn. Biotechnology and the advent of traits has really revolutionized the seed industry, and at Stine it's been no different. We've had to respond to that, and we have with our own biotechnology facility. I've got Dr. Bruce Held here, who's one of the co-directors of Stine Biotechnology. Bruce, can you tell me a little bit about what goes on at this facility?
Yes, we've been here, David, for over 15 years, and we specialize in this process called transformation, which has created those crops we're all familiar with, the herbicide-tolerant crops and the insect-resistant crops that contain Bt genes.
Okay, so how do you get those traits into the plants?
That's a good question. You have to get the genes through the plant cell wall, which is a huge barrier to this process, and that's the first step in the process.
Okay, so what kind of methods do you use to do that?
Well, you can use a biological method, agrobacterium, or you can use physical methods, and in particular, we use the aerosol beam injector.
Okay, which is this device here.
Exactly.
Can you tell me a little bit about how this machine works?
Sure. This is our proprietary device, and it works by first having a DNA solution metered into the top of the device, and here we create an aerosol, and then in this bottom chamber we'll put the plant tissue, which will be transformed, and we'll pull a vacuum in this bottom chamber. This vacuum will pull the droplets down through this small orifice, and when they enter that orifice, they're accelerated to supersonic speeds.
Wow.
And that's what gets the DNA into the cell.
So you just shoot a stream of DNA right into the plant tissue.
Exactly.
Now, how long does that take?
Well, this process here just takes a minute or two, and it's really short compared to the entire process of actually once getting the DNA into the cell and then selecting a cell with the DNA in it and regenerating a plant from that single cell. And that whole process can take 6 months to over a year.
Really? Okay, so it's not an overnight process.
No, it's not.
What kind of plant tissue do you use then to insert the trait into?
Well, we use a soybean embryogenic callus and corn immature embryos.
Oh, okay. So what's a device like this mean for Stine Seed Company? What are the benefits of having this technology, which is our own, transformation technology?
I think the main benefit, David, is it gives us freedom to operate. And it gives us unique capabilities to work with other traits that maybe nobody else, are working with.
So you can work with genes that you've discovered in your own lab, or you can also work with other companies who have a trait of interest that they want to get into genetics.
Exactly.
Fantastic. So Bruce, what's the payoff for our grower customers?
David, it's new traits and Stine genetics.
Great. Thanks, Bruce.
Yeah, you're welcome.
So Stine researchers are working to develop the traits that growers want packaging superior genetics from Stine to provide a choice for maximum yield and profitability. Thanks for joining us for today's tour. From our world-class soybean breeding program, to our corn breeding program, biotechnology assets, to our innovative production practices, it all adds up to choices of the traits growers want and the yields they demand.